Morning, students. Today is July the 11th, and we will start chapter 6, section 1. This is a short section, and it's an interesting section because it involves some of the things we have done in the past. We're going to be comparing probabilities with mean and median, mean and standard deviation. Okay. So it's about random variables. So what's a random variable? A random variable is a numerical measure of the outcome of a probability experiment. So its value is determined by chance. I'll give you an example. Suppose you're tossing a coin twice, and your random variable is how many times can you get ahead? If you toss a coin twice, you can get ahead 0 times, only tail. You can get ahead once, or you can get ahead twice. Those are your random variables. Okay. We're going to learn about how to find mean and standard deviation. And we're talking about discrete random variables. Okay. So a discrete random variable is a scenario like we just described. It's discrete, like there you can get ahead 0 times or 1 time or 2 times or 3 times, something like that. Continuous would be like somebody's weight. Okay. It could be anything between 10 and 20 and everything in between. But don't worry about the definition of continuous random variables. We'll go over it when we do it. Discrete random variables can take values that are discrete, like 0, 1, 2, 3, 4, 5. So let's look at some examples. So the number of A's earned in statistics class. All the students can get A's. That'll be 15. Only 14 could get A. Only 13, so on and so forth. Nobody could get A. So random variable X can take these values 0, 1, 2, 3, 4, all the way up to 15. The number of cars that travel through McDonald's drive-through in the next hour is a discrete random variable. Okay. In the next hour, how many cars could pass through? 0, 1, 2, 3, 4. It goes on and on. The speed of the next car that passes a state trooper this is a good example of a continuous random variable, right? It could be anything above, you know, 0, right? So there are some nice examples here, and we went over them. Okay, this is important. This is kind of a key point. The probabilities will always add up to 1, and each probability will be a positive number less than 1. So if you know it's a probability distribution of discrete random variable, each outcome will have a positive probability that is, of course, less than 1, and all the probabilities of your random variables should add up to 1. This is important. I have assigned many of the problems from 6.1 where this knowledge will come in handy. Okay. Now, how do we compute the mean? To compute the mean, we take each variable, multiply by its probability. That's all we do. It's really same as what we did in the past. Okay. Um, so it's a fairly basic concept. In this example, I'll do one example on Excel, okay, from your book. Um, Compute the mean of the discrete random from table 1. Don't worry, I don't have table 1 here, but let's see if we can find table 1. Why not? Give me 1 second, guys. I'll do a couple of problems for you on Excel. This is your table 1. Let's see what they're doing. So they want you to find the mean. So let's take a look. What this is saying is the probability that you'll get a zero is 0.01, 1 is 0.10, 2 is 0.38. This was about throwing basketball, okay? So they just gave you the probabilities. You're going to get three chances. You could miss all of them. You could hit once, twice, or three times, and the probabilities are on the right-hand side. If you add the probabilities, they do add up to one. I double-checked, and each probability is positive, but less than one or equal to one, and that's totally acceptable. That's what we're looking for. And to find the mean, what they did, 0 times 0.01, 1 times 0.01, 2 times 0.38, 3 times 0.51. And standard deviation definition is very, very similar. Let's go ahead and look at the definition of standard deviation. Okay, to find the standard deviation, you're going to be, I like this formula, the first one, the one we did. So treat probabilities as frequencies. Okay, when it comes to the frequencies, we divided it by total probability. We divided it by the total number of frequencies. But here, the probabilities add up to one. So dividing it by one is a non-issue. You don't need to. Okay, other than that, each outcome minus the mean squared multiplied by the probability and added up, square root is the standard deviation. And you don't have to worry about population or sample. So it really builds on the previous chapter that we did. All right, so let's go ahead and find one using Excel. I'm going to do it from scratch. So let's pick a problem from your book. Let me grab a problem from your book. For instance, let's see. In discrete probability distribution. Let's actually, guys, let's do this problem in detail, okay? Let's do this problem in detail. Now, about drawing the graph, I'm not going to draw the graph, guys, because your exam or your book will really give you the options of the graph, and you're going to pick it. There's nothing to it. It's like a histogram with a vertical line going up. So I won't draw the graph. That's the only thing I'll kind of skip. This is the question, and let's see what they want us to do. They want us to do these things. They want us to do these things. Okay. So let me carefully enter the data first. All right. Give me 1 second. Interesting. But that's okay. We'll survive it. No worries. The only catch is I have to enter it very, very carefully. I don't have it. I'm thinking, guys, let me do one from your MATLAB. Let me do a similar problem from your MATLAB, okay? So I don't feel comfortable entering the data manually. It's going to be a challenge. So I'm going to grab something like one of the homework problems I have assigned to you guys, okay? Let me pick something. Let's do this one. Okay. Okay. Let's do this one. All right. So actually, guys, if you don't mind, I'll do this one. All right. All right. It's similar to the one I want to do. If is the probability distribution to the right, in the probability distribution to the right, the random variable x represents the number of hits, number of hits the basketball player obtained in a game over the course of a season. Complete part A through F. Let's grab this. Just safer. I don't want to enter the data and enter something incorrect and mess up. Awesome. We have it. Now, the first thing I'm going to do is I'm going to check. My probabilities should add up to 1. And it's a problem. So from your text, so I'm sure it does. 1. Good. Now, what else do they want us to do? Let's find out. All right. Now, going back to this problem. What is the probability that a random selected player got? The player got is 2 hits. Okay, I'm getting a little ahead of ourselves. Okay, so they want you to choose the graph. Okay, now take a look, guys. Take a look. This is the best one because this is about 1.6. Clearly, this can be right. It's very easy to eliminate. Okay, this is less than 1. Okay, so you can analyze the graph. I'm not going to go over it. This is the best one, right? What do they want? We did A. All right, now they're saying verify this probability when we did. Draw the graph. We chose the right graph. Complete interpret the mean of the random variable. Okay, the mean, let's find the mean. All right, and we have our answers there. We'll check. To find the mean, we multiply each data point by its probability and add it up. Add up the whole thing. I'm getting 1.62. That's exactly what they got. We are happy. How do you interpret it? I would say if they, on average, they get about 1.6 hits. That's how mean is interpreted. Then I'm sure they want us to find the standard deviation. Okay, guys. So before I look at the answer, I'm going to find it. Okay, we are finding the standard deviation. To find the standard deviation, what do? We take these original numbers. I'm going to call them X here, and I'm going to recopy them. Okay, copying them right from here. And in the next column, I'm going to copy the mean. It's going to be the same, right? I'm going to subtract the mean, square them, and then I'm going to subtract the mean from each outcome. I'm going to square them and multiply them by the probability. The probabilities are right here. I'm actually, guys, I am going to put the probabilities right here. P of X. Again, just to show you what they are. Not that you have to do it exactly the way I'm doing it. All right, this is the mean. I'm going to write M. Yeah. Now, what I'm going to do here is I'm going to take this, subtract the mean, and square, and multiply the whole thing. I might as well put it here by the probability of each. So I get a bunch of these things. To find the standard deviation, I'm going to first find the sum. I don't have to divide by anything because the sum of the probabilities is 1. Here, this is going to be SUM of all this. Okay. Now, so I'm kind of, I've divided by the sum of the frequencies. It's going to be 1. Frequencies are kind of like probability. Okay. They're really, really the same, but you have to be a little careful. Okay. But they're conceptually, they're really the same. Not literally. Now, to find the standard deviation, you have to take the square root of this previous number. And we're going to soon find out if I messed up. This is what I'm getting, 1.17. Let's find out first. 1.17, so that's a good sign. Now, let's do some of these. What is the probability that in a random variable game, the player got 2 hits? Well, 0.2874. That's exactly what we got. That's coming from the table. No big deal. What is the probability that a random selected player, the player got more than 1 hit? Okay, guys. More than 1 hit means if you add 0.2874, let's add it. All those, okay, we're going to add them, and hopefully we're going to get the number they got. So, well, we can actually do it on Excel, isn't it? I'm going to add all of this, paste them here, add them here as follows. 49, that's exactly what they got. And that's it, guys. That's it. It's not a very difficult section. And well, let me go over one tiny thing, guys. One tiny thing. It's kind of, I wouldn't say it's a side note. It's called expected value. And let's discuss this. I forgot. Almost forgot. Maybe it'll come back again. I'm pretty sure. Yeah. So, guys, I'm going to share something with you before we wrap up. We're going to do it a little more later. Don't worry too much. What is expected value, guys? Expected value is really the mean. Okay. We call it expected value because if your mean, the way we found the mean, that is really a long-term average. So there is a nice problem here in your book. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of a policyholder. These policies have premiums that must be paid annually. Suppose an 18-year-old male buys this a year, like 25, 20, 250,000, 1 year term life insurance policy for 350, according to, so there is, okay. So they're saying they'll give you probability and they'll give you how much money you will get. And you're going to multiply how much money you will get by the probability. So think about it this way. What they're doing here, the probability that the person, so it's actually done from the perspective of the company. The probability they survive is very high, is 0.99 this, and they will make $300, the $350, the insurance company. And the probability that the person will die is very low right here. And if they die, how much money are they going to lose? Well, they're going to pay off this, but they did receive 350. They subtracted 350 from this large number, and they got this number, and they added up. So from their perspective, the expected value is this. So if they sell this policy to a lot of people, in the long run, in the long run, this company will make $84 per person. Okay. Now it's going to make a lot more sense when we work on the next section, but this is here. I went over it. I don't think I gave you any problems on expected value. So what we learned in this class today is how to find the mean and standard deviation of discrete probability distributions. And try the problem. You should be able to do all the problems from 6.1 without any trouble. And if you have any questions, always you can email me. I'll be happy to help you out. Thank you, guys.